All right, so we're making our way through 9.4. We got through like really basic stuff about the normal distribution. This is the main stuff that you want to know about, these three things here, that the mean and the median and the mode are the same thing in normal distribution. It's symmetric over that middle value, the mean, median, dash mode. And then also that 50% of the data is under the curve on the right and to the left of that middle value there. So what happens once we have all that information, what makes normal distributions really, really nice is that once you have a normal distribution, this other thing that's played into it as well called the empirical rule. So you'll hear this phrase used every now and then, the empirical rule. And what it represents is this nice thing that goes along with normal distributions, which have to do with these things called standard deviations. Standard deviations are kind of like these little check marks that go through a normal distribution that show how like well spread out the data is. So the standard deviation is like the spread of the data. The bigger that the standard deviation is relative to the mean, the more spread out the data is. In other words, the more flattened it looks, okay? And still symmetric over that central value. The smaller that the standard deviation is relative to the mean is going to give you a much more narrow distribution. So like think of it kind of like that, like where there's a central value and all the data is spread out in a very short space, okay? But the empirical rule allows us to use a normal distribution no matter what the standard deviation is relative to the mean, and it tells us a certain percentage of the data that's within these different standard deviations. So 68% of the data in a normal distribution is between one standard deviation of the mean. In other words, if I were to go, calculate the standard deviation, it's that little sigma x that we see in our calculator, or, you can use the formula for the standard deviation. That works as well. You can find that value. You can also find the mean or the average from the standard deviation, the mean or the average of the data that you collect, just by calculating the same way that you know how. And, if you know those values, you can figure out exactly what 68% or roughly 68% of the data falls under in that normal distribution curve. And, it looks like we're going to have an example of using that shortly, don't we? No, I guess we just have examples in a little bit of the z-score. So here, let me show you what this represents. Let's say that we had, let's see here, what's a nice normal distribution that we could have and just make up? How about like the, yeah, all right. So let's say that like the Phoenix Suns, right? So we have the Phoenix Suns. And let's say that the average score that they have in their games throughout an entire season, like maybe one of the Steve Nash era seasons, was maybe like 125 points per game. All right, so that's the average or the mean. And let's say that the standard deviation that you calculate with that from taking all the games and using the standard deviation formula, let's say that the standard deviation from that is, I don't know, like maybe 4.8 points per game. Okay, so you have a standard deviation that's equal to 4.8 points per game. All right, so here's how I can set all of this data up. So my mean, the average value, would go right in the middle of this normal distribution. So that'd be 125 points per game. Then for each of these little standard deviations that I have, this +1, +2, +3, and -1, -2, -3, that represents a certain number of times that I'm going to add that 4.8 onto it. So here's where you would want to use your calculator. So what I would do is I would take the 4.8 and I'd add that onto the 125 points per game. Okay, so if I add 125 and 4.8, and you know what? Let's backtrack. Let's make that an easier number. Let's just say 5, because we can't get like 0.8 points in a basketball game, can we? So let's just put 5 on there instead for the standard deviation. All right, so if we added on 5 to 125, that means that one standard deviation up would be 130 points. And then if we subtracted 5 from 125, we get 120. So the empirical rule states that out of all the games in the Suns season, that means that within one standard deviation, in other words, 120 to 130 points per game, or points in a game, that means that 68% of the games fall within this range right here. Now, if we went out to 2 standard deviations, I'd have to add on 5 twice. So adding on 5, so we have 125 in the middle. If I add on 5, that puts us at 130. If I add on another 5, that's 135. And then similarly, if I were to subtract 5, so subtract 1 standard deviation, that'd be 120 points in a game. And then if I subtracted another 5, that'd be 115 points in a game. All right, so within 2 standard deviations of the mean, in other words, that 125 points per game that we have, and that means that if we go out to 2 standard deviations, in other words, 115 points to 135 points, then that means that 95% of the games that the Suns played are between those 2 point values. You know, that's how many points that they'd scored, between 115 and 135 points. And then within 3 standard deviations, it goes up even higher. So if we expand out to 3 standard deviations, so in the middle, once again, is 125. If I add on 5, it's 130. Add on another 5, 135. Add on another 5, that'd be 140. So that's up to 3 standard deviations up above the mean. And then if we traveled back down below the mean, we'd be at 120. And then subtract another 5, that's 115. And subtract another 5, that's 110. So that means that the Suns, in 99.7% of their games, they scored between 3 standard deviations, so 140 points on the upper end and then 110 points on the lower end. So I hope that that makes sense to you in terms of using a little bit of a demonstration with this empirical rule. It's pretty easy stuff. Just make sure that you remember those values: 68% for 1 standard deviation up and down, 95% for up and down by 2 standard deviations, and then 99.7% going up and down by 3 standard deviations. And I want you to also remember that it's important to note that over this little line, the mean, right, that this is symmetric. So even though this is 68%, that means that this percentage and this percentage above and below the mean are the exact same. So how would I be able to find just the percentage of this group of games, you know, between 125 and 120 points? So all you'd have to do is just take that 68% and divide it by 2. So that gives you a 34% slice right there and another 34% slice over there. So it's completely symmetric. And if you remember, 50% of the data is below the mean and 50% of the data is above the mean, just like what we talked about in that previous video in 9.4. So don't forget about that stuff also when we're calculating some of this. And we'll see some of these examples in the homework, so just make sure to check out some of that. I think that's it for this video. Next one we're going to talk about is the z-score and also finding standardized scores from the z-score using either a table or using a calculator. We're, of course, going to use our calculator a lot because the tables are, you know, kind of a pain to use. All right, so that's it for this little part of the video, talking about just the introduction part of the empirical rule. Now, don't forget, if you have any questions, reach out to your teacher during their office hours, and they'll help you out. All right, that's it for this video. On to the next one.